to the channel for our second video for this year, and we will be looking at representing real numbers on number lines. Now this is a grade 10 topic, grade 10 math core if I can be more specific, and this is something that you are only going to be able to do if you have watched the previous video where I explained the real number system and also have gone to practice and ensure that you understand and know where the numbers fit in on the real number system. So today, like I said, we'll be focusing on representing real numbers, and we will be representing these real numbers in two different ways. Okay, so there are two ways that the numbers can be represented. The first way is by the set builder notation method. So the first way is the set builder notation, and the second method is your interval notation. So your interval notation. Now, whilst I'm going to go through the work, you will have to use your discretion whether are we using set builder notation or interval notation, as well as there are a few rules that I'm going to explain to you and a lot of notes that I'm going to give to you to help you understand the set builder notation as well as the interval notation. Okay, so first of all, there are important signs. So important signs, and you need to know these signs because they play a huge role in what you are about to do with regards to your set builder notation as well as the interval notation. So the first one is the smaller than sign. So your smaller than, okay? The one that's underneath it here, we all know also, is the equal sign, okay? Then we've got the bigger than. So this is the bigger than sign. Then we've got, with the smaller sign, we've got a smaller and equal to. So it could be small, smaller, and equal to. Okay? Or you could change out the and use the word or. So it could be smaller or equal to. Okay? Then the next one is the not equal sign. Then the final sign that we're going to look at is the bigger and or equal to sign. These signs are very important. So you're going to think to yourself now, yeah, this teacher is just saying that it's important and so on. I'm telling you it's important because once we're going to start with your actual way that it is represented in the set builder notation as well as in the interval notation, you are going to see why I'm saying it's important. Okay, then another thing that's very important is that the signs are given to you over here, but it also depends on how you read the signs. Okay, depends on which side the number is that is the smallest or the number is that is the biggest. Okay, so remember, these ones can also swap around. Okay, but I'll explain that to you once I get into the explanation of the set builder notation. Okay, I'm going to erase this. I'm going to give you other important signs that you also need to know. So, done with those signs, here comes the grade 10 work now. So, what I mean by grade 10 is the following. First one, curved brackets as given to you there, and an open dot. Okay, an open dot. Let me just write here open dot. This means that the number is not included, and I'll explain it to you now. So the number is not included. Okay, number is not included. Then, if you have a block bracket, such as these two here, and a dot that is colored in, then it means that it is a closed dot. And that closed dot represents the fact that the number is included. Okay, so the number is included. So, curved brackets, open dot, not included. Block brackets, closed dot, included. Okay, you need to understand that. It's very important, and I'm going to show you now why. Okay, so all the notes done now. We are going to start with the set builder notation, and you need to know this. This is very important. If you don't know this, you're going to fail this section, I'm telling you. So we're starting off with the set builder notation, and the two are very different. Okay, so let's focus on this one now. So, your first example. The first example states the following. I'm just going to say e.g. And remember, this is with regards to set builder notation. So it says represent, and here we go. They will always give you a variable. Okay? Please know that this is the variable. This is the variable. Then they're going to give you the next section, which is called the restriction. I will write everything down for you now. The restriction that you are working with. And then thirdly, they will give you the number system that they want you to work with. The number system that they want you to work with. Okay, first of all, the variable. So the variable that they are using is x. You can see that. Okay? Then the restriction. So the restriction that they give to you here is what you're going to plot on your number line, and that I will show you now when we complete this question. And then lastly, they give you the number system that you'll be using, or that you will be working with regards to your restriction. So the number system. And you need to know this. Very important. Okay. Now, you can see over here that you've got a -3, which means that your number line is going to start at -3. And how do I know that? Because if you look at this sign, it is open to the right side and not to the -3 side, which means it is going away from -3. So it's moving from -3 to the right side. Okay? Now, if you look at this sign over here, you can see that it is open to the 6, but it's also equal to the 6. So the number line is going to go all the way up to 6 over here. Okay, so when we represent this on the number line, let me just draw the number line. I'm going to have the 0 over here, -1, -2, -3. Remember, it can carry on. Then we have +1, 2, 3, 4, 5, and 6. Okay, and remember, it can carry on. Now, here is where the tricky part comes in, and this is what you need to understand. Now, remember, previously I said to you that The same as with those brackets and those dots. Okay? If you are working with a symbol like this or like this, this means that the number is not included. Okay? But soon as a symbol has that equal attached to it, the number is included. It's the same as those dots. If the dot is open or the bracket is curved, the number is not included. But as soon as the bracket is a block bracket and the dot is colored in, the number is included. Okay, now these signs work exactly the same. Included, not included. So look here. So we start at -3, which is over here. The sign is open to the right, which means it moves away from the -3 to the right. And because the symbol or the sign is not one of these, it means that this number is not included. So on the number line at the 3, you're going to make an open dot. Okay? Then we go to the 6. Now with the 6, the number, or rather the sign, is open to the 6. But the other thing that it has is this little line here that says that it is bigger than x, but it is equal to 6. So, because it has this symbol over here, it is included. So, in inclusion tells you that it has to have a colored in dot. And there we go. Now, because it runs from -3 all the way to 6, you need to connect these dots with your ruler and a pencil. And there you've represented the builder notation on a number line. So the way that you read this is the fact that x is bigger than -3, so that's why we start at -3, but x is smaller than and equal to 6. That's why we end at 6. Because this is not in an inclusive symbol, we use an open dot, and because this is an inclusive symbol, we use a closed dot. Now, what does the third part mean over here? It means that when you look at your real number system that I explained to you yesterday, you would know that real numbers are represented by an R. So you are working with the real number system. All these numbers over here fall in the real number system. Meaning, if you look at the number line, you've got negatives, you've got 0, and you've got positives, which means you are focusing on natural numbers, which start at 1 and move all the way up to positive infinity. You're including whole numbers, which start at 0 and move all the way up, as well as you include integers that consist out of negatives, as well as positive values, as well as includes 0. Okay, so you're including all of these. Okay, let's carry on to the next set builder notation question. So our next set builder notation question looks as follows. Okay? So it says represent and here is your set builder notation. So we're going to use the variable x. Okay? Then here's our restriction. So it's a 2. We've got the x here, 5, and the number system that we are going to make use of is integers. So if you watch the video that I posted 2 days ago, you would know what the Z stands for, and that would be integers. And they say that you need to represent this on a number line. And what numbers must we focus on the number line? Only integers. Nothing else. Not whole numbers, nothing like that. Any values that fall under integers. Okay, what are we using? We are using x as a variable. So we now need to go and read this to yourself first before you draw that number line. Now, look here. So we start at 2. What you do see here is that x is bigger than 2 but equal to 2 as well, which means that 2 will be getting a closed dot. Then x is smaller than 5, but it's also equal to 5, which means that it also gets a closed dot. Now, because you are representing integers and not including all the other numbers, you are going to do it this way. So your number line, this is just going to be a short number line. Oh, look at that arrow. So, first one is 2. I'm going to start at 2 because it starts at 2 there. Then we're going to go to 3, 4, then 5. So we said that it starts at 2 but also includes 2. There we go. Then it ends at 5. Okay, but it's also equal to 5, so it includes 5. But now because you're working with integers and you're not including all the other numbers, only integers, which means you're not including the fractions in between, like 2.5, 3.5, 4.5, etc. You need to go and put dots at every single number that is an integer. Remember, real numbers include everything. Mixed numbers, recurring decimals, the what do you call it? The, oh my goodness, fractions like common fractions, improper fractions, everything like that. Real numbers include. That's why we drew the line like we did in the previous question. In this question, they only focus on integers. So integers are only values that are negative and positive that increases in multiples of 1. So 1, 2, 3, 4, 5. That is why you cannot draw the line, because the line covers everything, such as the fractions and so on and so forth. So the reason for the dots is because we're only focusing on integers in this question. Okay, next question. Just going to do this. So, next question, we've got x and then we've got x, yeah, what do we have there? 5, oh, there we go. And then we have x, it's an element of natural numbers. There we go. Okay, now in this question, let's break it down again. So we're working with the variable x. Cool. Now, our restriction. We only have one restriction. Okay. They say x is smaller than 5, but it's also equal to 5. So anything from 5 moving downwards. Okay. But now, our number system that we're working with is natural numbers. And if you watch the other video to sharpen your skills, you would know that natural numbers start at 1 and it moves in multiples of 1 all the way to positive infinity. Please also remember that natural numbers works the same as integers and does not include fractions. So, like the first question where we drew the line, you are not going to draw a line at all, because natural numbers only focuses on numbers that are counted in multiples of 1. So 1, 2, 3, 4, 5. Now, our number system that we are going to draw looks as follows. I'm going to start at 0, 1, 2, 3, 4, and I'm going to end at 5 because That's where we're going to start. Okay. Now, they said an element of natural numbers. This sign means that it is included. So I'm going to draw my colored in dot. Okay. And now, everything smaller than 5 that is a natural number needs to be included. No drawing of lines, because natural numbers do not include fractions. So 4 is a natural number, 3 is a natural number, 2 is a natural number, and 1 is a natural number. 0 is a whole number, it's not a natural number. So that is how you draw your number line, and that is how you represent it on your number line. Okay, I'm going to do one more with regards to drawing your number lines with set builder notation. Then I'm going to swap it around. Okay, next question. So we're working with a variable x. We've got x, we've got the sign, and then we've got the 4. And then they say x is an element of a real number. So a real number, again, now it includes whole numbers, natural numbers, integers, fractions, mixed fractions, recurring decimals, etc., etc. It includes the whole spectrum. Also your irrational numbers. Okay, now we're starting at 4. And they say that x is smaller than 4, but we're working with real numbers. So we include everything. So now we're going to draw a line again. Now, 4 is not included, so it has to be an open dot. So when I draw my number line, here we go. I'm going to start with 4 over here. 3, 2, 1, 0, -1. And obviously it will carry on. Now, we start at 4, it's not included, so open dot, and the notation includes all the real numbers. So, we draw a line all the way to -1, and we put an arrow because it can carry on all the way to -infinity. It includes all the numbers. And that is how you do a question like that. Okay. Now, we've done it where you are given the set builder notation, but you draw the number line. Now I'm going to give you the number line, and you have to write the set builder notation. Okay, here's the number line. So we've got the following. There we go. I'm going to put a -2. Then I'm going to put a +3. -2 is going to have a closed dot, and 3 I'm going to give an open dot, and then I'm going to connect the 2. Okay, now look here. First thing that has to come to mind, when we write a set builder notation, remember your curly brackets. Okay. Second thing, you need to remember to write your variable that you are utilizing. Okay. Thirdly, you now need to go and read this thing to yourself so that when you write it down here, you know exactly what you are talking about. So, first of all, we start at what? -2. So, -2 I've written. Is -2 included or excluded? It is included because the dot is colored in, which means that we are going to use a sign with an equal sign as well. But you now need to see that the line is moving away from -2, which means that your bracket, or rather your sign, has to be open away from 2. You then put the variable x in, and now you need to understand that x is smaller than 3, which means that the other sign over here will be open towards the 3. What you also now need to understand is that 3 is not included, so you're not going to put in an equal sign, okay? Then, because there's a line, it means it includes everything. And when I tell you everything, everything, fractions, the whole lot. So, the number system that you are going to use would be real numbers. And there you go. You've written your set builder notation from a number line. Okay, let me give you the next one. So here's your next number line. So your next number line will look as follows. Let's see here. I'm going to start at -1, 0, +1, +2, +3. I'm going to stop there. Then I'm going to color them in as follows. So all of them are included. Okay? First thing that has to come to mind, oh, I've got negatives, I've got the 0, I've got positives. So the number system that I'm working with would be integers. That's what I'm working with. Okay? So, first of all, curly bracket, you write your variable down, which is x, and now you have started at -1. So -1. And because it's dotted like this, we know that integers do not include fractions and all the other stuff that comes with it, and only focuses on values that can be counted in multiples of 1s. So we start at -1, it's included, and we are moving to the right, so it's moving away. So your sign will show away from -1. Okay, so x would be will be bigger and equal to -1, but x will be smaller and equal to 3 in this case. Okay, then, okay, let me just explain this. The reason why x is smaller and equal to 3 is because it doesn't carry on counting to 4, 5, 6, 7, etc. It stops there, which means the number falls between -1 and 3. That's where the numbers fall. Okay, that's what it means. Then, we have established that we are using integers, so our number system, x is an element of of integers. And we draw the z, and there you have it. Okay, going to do one more, then I'm quickly going to run into the interval notation. So, here we go. Here's the number line. I'm going to put -7 over here. And then I'm going to give it an open dot. And let me just do this. And I'm going to run it to the right. There we go. Now to write the set builder notation. Let me give you a shortcut. Anytime that there's a line that is drawn, or that you have to draw a line, you know that you're including all the numbers under the real numbers. These include whole numbers, natural numbers, integers, fractions, irrational numbers, rational numbers, all those numbers, the whole thing. Okay, so when there's a line, it's always the element of real numbers. Please keep that in mind. Okay, now your little curly bracket, you are working with x as your variable. Okay, then there's only one number, which means you are not going to start with a number. You are going to start with x. Now with that, it tells you that -7, -7 that is placed over here is smaller than x. Why do I say that? Because from -7 the line goes to the right. So -7 is smaller than x, which means x moves into the positive values. That's why it goes to the right. -7 will be written, and it is not included, so the dot is open, so you're just going to put the sign without an equal to. Then, because there's a line, x would be an element of real numbers, so it includes everything for real number, for the real number system. Okay. there you go. So we've sorted the set builder notation in 2 ways. These are the 2 ways they can ask it to you. Make sure you know it. These are easy marks for free, I'm telling you. Okay, now we need to go to the following. Interval notation. So interval notation works with the brackets that I showed you. Interval notation works with the brackets that I showed you. Remember the block brackets as well as the curve brackets. Okay. And interval notation also has to be represented on a number line or the other way around. Okay, so vice versa. So first of all, the first type of question that they will ask you is the following. So they will say represent the following interval notation on a number line. And then they will give you the interval notation. Now the interval notation is not represented the same way as the set builder notation, I'm telling you. Please don't make that mistake. So here's an example of how they will give you the interval notation. I'm going to do a curved bracket, -3, 6, and then I'm going to do a block bracket. Remember, remember, please, curved brackets are open dots, they're not included. Block brackets are closed dots, which means that the number is included. Okay, so so to draw the following, okay, you're going to do it like this. So you're going to draw the number line. We are going to start at -3. Okay? And we're going to end at +6. Now, why am I doing this? Why do I not have element of real numbers, etc., etc.? That does not matter at this stage. Okay? The only thing that you need to know here is when am I using an open dot? When am I using a closed dot? Okay. Now, this curved bracket over here tells you that -3 is not included. So it needs an open dot. So you draw an open dot. The block bracket here by 6 tells you that 6 is included. So it needs a closed dot. And you're counting from -3 all the way to 6. And that's where it stops. So we need to connect the dots. Okay. Another one that I've got here. So I'm going to draw it here. So x element, I'm going to do a block bracket, -2, +2, and then from another block bracket. Both these brackets tell you that they are included, so they need colored in dots. So -2, +2, it's included. Oh, this one's also included. There we go. Color it in. Connect the dots. Done and dusted. Okay. Let me just erase here. Here's the next one. Let's see. I'm going to use this one. So x element of, I'm going to do a block bracket here. I'm going to say 4, and then I'm going to use infinity, and then a curve bracket. Oh, okay. So for the question represented here, infinity is not included, but 4 is included. So we're going to start it with a black dot, a colored in dot. And infinity goes on forever. So the way that you would do this one is as follows. So you draw your number line, you put in 4. Remember 4 is included because the bracket tells me that it is. And infinity goes on forever and it is not included. So from the dot, you draw a line with an arrow. And that's all you do. Okay. Then, here's a tricky one that I'm going to do with you. So I'm going to erase this one now. So, we'll do x is an element of the following. So I'm going to do a block bracket, negative 1 and 1. I'm going to do a curved one there, and then I'm going to put a u in here. Okay? Then I'm going to do a block bracket, 12, and that one goes up until infinity with a curved bracket. Okay, now you're going to ask me, so what does this mean? This means union. Or you could say it means or. So, this notation, this interval notation, or this interval notation. Okay, and you're going to represent both of them on one number line. Okay, so after I'm done representing it on a number line, I'll show you how to write it in set builder notation as well. Okay, so here we go, number line. We're going to go with negative 1 and 1 because we've got two numbers there. And then we're going to go to 12, which is over here, and then just close that off there. Now, let's start with this one. So we're going to represent this one first, and then we're going to go to the other one. So, negative 1 is included because the bracket tells me that it is. Okay? So I'm going to make a colored in dot. Then, positive 1 is not included because the curved bracket tells me it's not included. So I make a open dot. And these two I can connect. Okay, now we're moving to this one. This bracket tells me that the 12 is included, but the infinity is not included. Okay, and it has to run all the way to infinity. So all we're going to do here is we're going to draw a line and just show an arrow to represent that part of the interval notation. So this interval notation is on its own here, and this interval notation over here is on its own over here. Now, to write it in set builder notation, this is what you have to do. Okay, remember set builder notation, we always start off with the little curly bracket. Okay, that one looks a bit sick, but we'll carry on with whatever we have to now. So, our variable always comes in, remember that, the variable is always present. And then we're going to start with the first one, which is over here. Okay? And after that, we will move on to the next one. So the first one, which means we've got two numbers. So we're going to start at negative 1. Negative 1 was included. Okay? And the sign for inclusion always has an equal to it. Okay? And the reason it is closed towards the negative 1 is because x is bigger than negative 1. Okay? Then, positive 1 was not included. Okay? Which means you are not going to use a sign that has an equal sign to it, and you're going to use the normal sign with the 1 represented. So, negative 1 is smaller than x, but equal to. Okay? Then x is smaller than positive 1, but not equal to positive 1. Okay? That's the first part. Now, inside that notation you write or. Now we're going to represent this one. And because it goes all the way to infinity, you're going to write it this way. So we're then going to say x is bigger than 12 because it goes from 12 to the right. But it's also equal to 12 because of the block bracket. It shows that 12 is included in this notation. Okay? And because it runs to infinity and because we had a line drawn here between the numbers, you cannot use specific number systems such as natural numbers, integers, etc. because your irrational as well as rational numbers are included, which means your fractions are included. So your number system that you're going to use here would be the element of real numbers, and there is your set builder notation from this. Okay guys, that is it for today. I hope that I've explained everything very well to you, that you understood the explanation, and that this really helps you out, especially you guys that are going to grade 10 now. You should start working tomorrow, if not tomorrow then latest Monday. So I hope this helps you out. The first video as well as this video that I set out is what you will start with in grade 10 and what you will be working on. Then grade 9s and 8s, the first video that I posted, please be sure to know what's going on there, because you guys will also be doing number systems but not this work. You guys will do more of other type of work than what the grade 10s are doing. So yet again, thank you for tuning in, thank you for growing the channel, thank you for always being there to support us. We appreciate it. Please get more people involved, and as always, see you next time. Have a good day. Bye bye.